Hello, my friends of class 11 science. Today we are going to do a bit more practice about of differentiation, the application and its formula. Uh, so this is the formula which we have learned, the very first, the simple formula. We understand the formula first. ddx of x to the power n is equals to nx to the power n minus 1. What happens over here is n goes up to two places, once as a coefficient of x, and then we just subtract minus 1 like this, and x is simply written like this. So this is our formula. We have to apply this to solve few problems. Okay, now the question, ddx of x to the power minus 3, ddx to the power x minus 3. Apply the formula as it is. Okay, see what we are doing. Minus 3, first it goes over here, minus 3 written as it is. Then we write it over here, it's minus 3 minus 1. It was n minus 1, so it minus 3 minus 1. And then x is written just over here. And then what is minus 3 minus 1? Minus 3 minus 1 equals to 4. So this is how this problem is solved. Next question, ddx of x to the power minus 19. Apply the formula as it is. This is how it is done. Okay, I shall explain this once more to you. See, minus 19 goes at two places, once over here and once over here. Minus 1 to be done, and then minus 19 minus 1 will be equal to minus 20. Got it? So this is how we solve this question. Next question, ddx of x to the power minus 3 by 4. Do nothing but simply apply the formula. Okay, the solution to this question. See, if you think you can solve this question, just give this video a pause and do it yourself on pen and paper, and then just confirm that whether your answer or your method is correct or not, or if you have done any mistake, then again look into the solution, that what is the mistake done by you. Okay, this is the question and this is the solution. Pause if you want to try it by yourself. Okay, this is the solution. Now let us go for the next question. ddx of square root of x. Now we know that the square root of x can be written as x to the power 1 by 2, and it can be solved like this. See, ddx of square root of x. Instead of square root of x, I have written x to the power 1 by 2, and then again the same thing to be done. Minus 1 by 2 written at two places, once over here, and then 1 by 2 minus 1 gives you what? Gives you minus 1 by 2, and x to the power minus 1 by 2, because of the negative sign it is written in the denominator, and because of the power half it is becoming the square root. So this can be written like this. Okay, this is another solution. Now the next problem, we have one more formula. See, this is ddx of ky. What is k? K is a constant. And what is y? Y is any function, or say any relation. The number y, the variable y, has some relation with variable x. But k is a constant. Okay, constant means something which does not change. So what you can do with that constant, see, you can simply take this constant out of the differentiation. Okay, the constant over here is inside this differentiation, but you can take this outside. Now see, the k comes outside the differentiation. If k is a constant number, you can always do this. Let's see an example based on this. Here we have this question, ddx of 3x square. Now in this 3x square, what is constant? 3 is constant. So what happens to that 3? 3 can be taken outside. You can see this. This was 3, and what I have done, I have taken this 3 from inside the differentiation to this place outside, and where it appears now, it appears over here. And what happens to the rest of the problem, d dx of x square? You know how to solve it. D dx of x square, see, 3 is over here, and this d dx of x square is solved. It is 2x. And now what? Now we multiply this 3 and 2, and what does it give? It gives 6. So what is the solution for this? It is 6x. Are you getting it? If you don't get it, watch the video again. Okay. Now another example, d dz of 10 square root of z. Now what is to be done? Identify this 10. 10 is what? 10 is a constant. So what will happen to 10? 10 will simply come out. 10 will be written outside like this. And then what will remain? D dz of square root of z, that you can solve by yourself. Let us see the solution. See. Okay. See this 10. The 10 comes out, and d dz of square root of z. Square root of z can be written as z to the power half. And then you know how to solve this. Half z to the power half minus 1. Okay. Half minus 1 is what? It is minus half. And because z to the power minus 1 by 2, it is written as 1 over square root of z. This 2 will cancel out with this 10. And this will give 5. I'm saying again, watch the video again if you do not understand any step. Done? Let's go to the next thing. Is d d theta of pi theta square. Now pi has a fixed value. So what is pi? Pi becomes a constant. What will be, how we'll be dealing with this pi, that we will be taking this pi simply outside at this place, and then we will solve the remaining problem. This one. Now solve it by yourself. Okay. Now let's go to yet another formula. This is another formula or the working principle. D dx of u plus minus v is equals to du dx plus dv dx. What is to be done over here? See, u, first you differentiate u, and then you differentiate v with respect to x. Whatever sign is there, if plus is there, then here plus will appear, and if minus is there at this place, then minus will appear at this place. Okay, so the formula is d dx of u plus minus v is equal to d dx of u plus minus d dx of v. Okay, now let's see an example. D dx of 3x plus x square. Okay, now what is here? In the formula we had u plus v, so this is in place of u and this is in place of v. Okay, follow the formula and write it like this. D dx of 3x plus x square is equals to, first 3x is written, then d dx of x square. Okay, there is a square over here and there is a square. Okay, now 3, what happens to 3? 3 comes out, it jumps out. What is remaining? Dx by dx. And what is d dx of x square? D dx of x square is 2x. 3 goes outside, which is written over here, and then dx by dx. You know what is 2 by 2? It's equals to 1. 10 by 10 is equals to 1. Z by z is equals to 1. So this dx, they will cancel out, and what this will be? This will be simply 1. Okay, so what the answer is? The answer is 3 plus 2x. Got it? Another example, d dx of x square minus 2x raised to 4. Okay, now here, this is in the place of u, this is in the place of v. Use the formula. This is how it is done. See now, this x square is written over here. We differentiate this x square first, then minus sign, so here again it is minus sign, and then we differentiate 2x raised to 4. Now ddx of x square dot dx, ddx of x square, it is simply what? It is simply 2x. What happens to this 2? This 2 will jump out, and then what remains is ddx of x to the power 4. Okay. Now, what is 2x? 2x is simply 2x. 2 is written just like this. And the differentiation of ddx of x to the power 4, you know how to do it. It is 4x cube. Okay. I'm cutting few steps because now I think you are mature enough to do this. Okay. This 4 and 2 gets multiplied, and this is your final answer. Got it? Now another question. This one is going to give you a little trouble. This is this is differentiation of z raised to 4 with respect to z square. Okay, differentiation of z raised to 4 with respect to z square. Now there are two methods to solve this question. The first method is this. Suppose we take z square equals to n. What we take? Z square equal to n. So this form gets reduced to this form, this one. Okay, now we simply differentiate it. It's what? Equals to 2n, and now what you do, you just put the value of n, which is equals to z square. So the answer is 2z square. All right, now there is one more method. You can do this method, or you can go with another method. This one. See, what I have done over here is in the numerator I had z raised to 4, in the denominator I had z square. Now what I have done, I have multiplied this term with dz and divided again this term with dz. Alright, now you can differentiate this z raised to 4 by dz. You can differentiate this, what it is, 4z cube. And now see what happens to this. What happens to this dz? Denominator of the denominator goes to numerator. So where I have taken this numerator, I have taken this numerator as the denominator of the denominator. Okay. Now forget everything else. Now you can solve this. d dz of z square. What is d dz of z square? d dz of z square is 2z. And now you can mutually cancel them, multiply them, divide them to get the final answer 2z square. So whether you do this method or the previous method, the answers are going to remain same. Okay, but you have to learn both the methods because sometimes this is useful, sometimes that is useful. Now this one. Okay. So differentiation of theta cube with respect to theta squared. How it is done? See. Again, what I have done, notice I have multiplied it this term with d theta and again divided this term with d theta. Why? Because now this one, d theta cube by d theta, it can be solved as 3 theta square, and this d theta now goes into denominator of denominator, and now you can solve this differentiation. What it is? It is 2 theta. Now going for the mutual out cancellations and next things, what do you get is 3 by 2 theta. Now I advise you to do this with the other method also, taking the value of theta square as something you know how to do now. Got it? There will be more practice questions. I will be solving few questions like this. If you don't get any of them, you just have to ask your doubts.